leading zeros from an IP address. So given an IP address, remove leading zeros from the IP address. Note that our IP address here can be a little different. You can have numbers greater than 255. So it's not normal like our IP address that we are studying, like there can be some numbers that is greater than 255. Okay. Also, it does not necessarily have 4 numbers. The count can be lesser or more. Okay. So it's typically according to the problem, like this is a special IP address and we need to remove the leading zeros from it. So let's consider the first example, 100.020.003.400, and the answer is 100.20.3.400. So here it was 0 to 0, so this is the leading zero and we removed it and have 20. Okay, and in this case it was 003 and there was 2 zeros and we remove all this and just return this 3. This is 400. So the next example, it's 100. Okay, 000 010 099. So in this case, like all the numbers are 0. So this is one of an edge case, like one case that we need to handle separately or we need to take care, because sometimes if we missed about this condition, if we remove all this, like the answer might come like 100.10.999. So we also need to take care of this condition, like all the numbers are becoming 0. So yeah, so let's consider one example, this one. Okay, so let's say we are having one number 100.001.111.222. So basically we need to remove these 2 zeros. I need to return 100.111.222. So this is what we need to return at last. So the first thing that we can do here is we can just split it based on these dots and get all these individual or all these individual groups. So like we can get 100, 001, 111 and 222. So we will be getting like this after just splitting. Now we can just take this 100 and can keep a pointer here. Okay, so we take 100, we keep a pointer here. We just check whether this is 0. It is not 0, so we just include the whole 100 in our answer. So we include all our 100 in our answer. Okay, since we have no zeros, we can just directly take the whole. Now we go to this one, next string 001, and we keep a pointer here and we check whether this is 0. Yes, it's 0, so we don't want to include this, so we move to the next one, and this is also 0, so again we don't want that and we move to this one, and this is not 0, so we only need this one, so we can have 1 here. Okay, that's also fine. Now same way we keep a pointer here, no, we keep a pointer here, no, 0, we also keep a pointer here, no 0, so it will be 111 dot. So same way 222. So that's the idea. In some cases, like if we are considering, in some cases if we do like this, and sometimes a dot can come here, and we can just consider only this much at the very final result in order to get a result, or like on the first traversal, like consider only this one and handle this one separately, so that we can get rid of the last dot that will be coming as a part of a for loop or as a part of a loop in our logic implementation. So that can be a way of doing. So we can also just try another example. So basically this is the idea or the logic that we can do, and then it's just the matter of using any language. In Java, like we can make use of a string builder in order to create mutable string objects, and just have a while loop that goes through each of the word by keeping the pointer and checking like whether that character is 0 or not, the first character is 0 or not. So let's have another example. 0 0 0 dot 0 0 0 dot 0 0 0. So this is one of the IP address. Okay, so let's say we are grouping this, we are taking this, splitting it, okay, based on dot. So we will be getting this as 1, this as a string, and this also string in an array. So we will be having 0 0 0, then 0 0 0 as our second element, and 0 0 0 as our third element. Okay, now same way, like we will be keeping a pointer here. Okay, so this is equal to 0 and we don't want to include that, so we move to here. And this is also equal to 0, we don't want that in our answer, and we move to here. And this is also equal to 0. So according to our logic, like if we continue like this without checking a condition, like if our pointer is equal to the length, here it's 3, so the length of the split string, okay, here s means this is s, okay, this is s, this is s, this is s. So if the pointer is equal to the length of s, then we need to include 1 0. So we need to have a 0 in our answer, then dot. Okay, that's the first, that's with this group. Now we can move ahead with this one. Okay, so we have we keep a pointer here, this is equal to 0, we don't want to include that. This is another 0, we also don't want to include that. This also is 0. So our pointer reaches here and we hit this condition, our pointer is equal to length of s, so we need to include 1 0. This means like we reach the end of that splitted part, and what we see is the whole string is 0. So if we didn't handle this condition, like we will be having dot, like in our final answer it will be dot dot dot, which is not what we need. We need 0, so 0. The same way we will be keeping a pointer here, it's 0, we move the pointer here, it's 0, we move the pointer here, it's also 0. So we will be checking whether the pointer is equal to length of s, so this is also 0. So this is basically our condition, and now we can just try to do. So even though like the constraint is given as like the length will be 1, like I'm always happy to have this check at the first. Return empty. Let's have length of string is equal to s of length. We can split the string based on dot. So like in Java we will be getting an array of split, and the function is s dot split, and there are different way how we can split based on dot, and we can find it in like if we do a Google search, like we can find some 2 or 3 different steps of doing this split, and this is one of the way like we can do this split also. So now we will be getting 100, 0 to 0, 0 0 3 400 as different reference arrays. Now first we will be handling the first 3 alone, and the last one is handled separately. Like we will be putting a loop like this for let also take length of split is equal to split dot length. Okay, so we will be just doing for int I is equal to 0, I is less than length of split minus 1 I plus plus. Okay, so we are considering up to this one. Now we need a string builder. So we can also just use plus operator, but string builder is more efficient in Java, because if we do the normal string concatenation, like new objects will be created as string is immutable in Java. So we can make use of the string builder and then convert it back to this sb.string. So our final answer will be sb.toString. Now we need to do certain steps, like we are taking this word, okay, we are keeping a pointer at this one, checking whether it is 0 or not. If it is not 0, we'll be just taking the whole. So we can make a helper function. Okay, so remove leading 0 of the word at the index I. We need to append it into string builder sb, and we need to take the word from split. Okay, now we need dot, because after each of this we need a dot. So that's why, like, I am just considering up to length of split minus 1. Otherwise, like, a dot will come at the very end, and we need to just only consider this much, expect that dot. Now we can just separately handle the last character. So length of split minus 1 word will be stored here and can be gathered from split. So now we can try to complete this helper function. So this means, like, we can do the logic inside these loops, but we will be duplicating the code, like writing the code 2 times. So instead of that, like, we can just, as we are doing the same thing, we can just put it inside a helper method, and it's also a good way to go. So we can do that way. Let's have the index, and let's have the string builder sb. Instead of passing this index and split, like, we can directly pass the word, but I can't go with this way. Okay, so string current word is equal to split of index. Now we can have our pointer equal to 0. So while, okay, length of current word is equal to current word dot length. So we also need to take care of the out of one condition, like, yeah. So if pointer is less than length of current word and that current word dot char of I is 0, then we are just skipping it, we are just moving the pointer. So here, so if we just do this and just now after this, like, we will be skipping the so if we consider 0 0 0 0 3 alone, like, we see we keep a pointer here, okay, and word dot caret of 0 is 0, so we move to the next 0. It's also 0, so we move to next word, that is 3. So now we only need to add this 3. So sb dot append of current word dot substring of pointer. Okay, now if we do this, like, we think that we are done, but we will get wrong in this condition, like already added, like, this is a special condition. So what happens, like, with only this logic, this much logic, what happens to this 0 0 0 alone? So it's 0, so current word dot caret of I is 0. Okay, we skipped it. Next one is also 0, we again skipped it. Next one is also 0, we again skipped it. So our pointer moves out. so there is no substring that we can take care of here, so it will be just a dot. That not what we needed. So we need to check if pointer is equal to the length of current word, then we need to add 0. So I think this will do the trick. So here for the splitting part, it is taking a big of s, and here also like we are going through, and this is also big of s itself, like s means big of n. Here n is the whole string s, the whole input, length of the whole input. So the maximum, the worst complexity will be like big of s itself. We are creating extra space as like the array split for splitting. So we are creating extra space, and we are also storing this s character. So big of length of s is the space complexity. So we can just check whether we have so yeah, this pointer so 123 400, we are done, we are good with that. Now let's need to check with the 0 case, because we don't want just a dot, we need 0 in that case. 0 1 0. Okay, we can just put else here. Now we can also just add 0 0 0 0 0 0. Okay, so our answer would be 0.0.0. That's what we are expecting, and that's what we are getting. Now we can finally submit it.